So my name's Professor Hilary Ranson. I work in the Department of Vector Biology at Liverpool School of Tropical Medicine. And the department here has got an international reputation for its work on insecticide resistance, particularly in mosquitoes. And for many years now, we've been looking at what the causes and the consequences of resistance are for disease control. Because LSTM has a real focus on translation, our work doesn't just look at the describing a problem, because clearly resistance is a very big problem for disease control, particularly for control of malaria and dengue, but we also work with multiple stakeholders to try and develop and implement solutions to the problem. We were one of the first groups to identify the problem of pyrethroid resistance in malaria mosquitoes in Africa. And we spent many years looking at what are the causes, what's the molecular mechanisms responsible for that resistance. And we identified one of the most potent resistance mechanisms, and that is overexpression or increased levels of a family of enzymes known as cytochrome P450s. Now there's a known inhibitor that can block the action of these enzymes. It's a chemical known as PBO. So we were then able to work with stakeholders in industry and partners to look at how we might be able to use this information about the main resistance mechanisms to develop new nets that would overcome resistance. So now one of the big innovations in terms of malaria vector control is the use of nets containing PBOs. They contain the pyrethroids, the insecticide plus this inhibitor of this resistance mechanism PBO. And PBO bednets are now being rolled out across many countries in Africa. Another example where our work on mosquito biology and behaviour has led to real innovations in this space is the work that we've been doing on looking at how mosquitoes actually interact with a bednet. So look, by doing some filming of how mosquitoes respond to somebody sleeping under a net as they try and enter a house and try and get a blood meal, we found that the mosquitoes predominantly come to the surface of the net, the top surface of the net. And that information has been invaluable for net manufacturers to think of innovative new ways in which they might apply insecticides to nets. So, for example, we've looked at putting barriers just on the nets that contain a different, on the top of the nets that just contain another insecticide that maybe might be too costly to put over the entire net. And this enables us to expand the range of insecticides that can be used